Welcome to chemistry classes. Today's topic is electrochemical cells. Electrochemical cells. Let us define electrochemical cell at first. A cell which can convert chemical energy into electrical energy. Electrical energy is called electrochemical cell. Okay. A cell which can convert chemical energy into electrical energy is called as electrochemical cell. Okay. The general example for electrochemical cell is galvanic cell. Galvanic cell. This is also called as voltaic cell. Voltaic cell. Okay. Now let us see the construction of voltaic cell by taking zinc and copper. Okay. Each and every electrochemical cell is consist of two half cells. That is anodic half cell and cathodic half cell. Okay. Anodic half cell is to be taken at left side according to IUPAC. In case of galvanic cell, the anodic half cell is consist of zinc anode and it is immersed in 1m ZnSO4 solution which is consist of Zn2 plus ions. Here concentration is 1m. Concentration is 1m. This is anodic half cell. Now let us go for cathodic half cell. Cathodic half cell is consist of copper rod as cathode. Copper rod as cathode. Here the cathode is denoted by plus. In case of electrochemical cells, anode denoted with minus, cathode denoted with plus. Here copper rod is used as anode, cathode, and the solution of electrolyte contains 1mCu2 plus ions. 1mCu2 plus ions. Okay. The both electrodes is connected to a voltmeter by means of a copper wire. This copper wire is helpful in transfer of electrons. Now, these two half cells is connected through a salt bridge. Salt bridge is an inversed U-shaped glass tube which contains strong electrolyte like KCl, potassium chloride. This is significant in completing circuit and prevent polarization. That is the importance of salt bridge. So this is complete construction of electrochemical cell. Now let us consider the reactions takes place at anode side and cathode side. At anode side, oxidation will take place. Here at anodes, let us see what will happen at anode side means zinc gives 2 electrons or loses 2 electrons and form as Zn2 plus ions. Zn2 plus ions. This is oxidation reaction. Oxidation reaction. In electrochemistry, at anode always oxidation takes place. Okay. Here at cathodic side, let us see what will happen. So here 2 electrons are there. At cathodic side, let us see what will happen. Here usually cathodic side reduction reaction takes place. Reduction reaction takes place. Here what will happen? Copper means Cu2 plus ions gains 2 electrons to give copper, to give C. Okay. So here once again I am repeating. At anodic side oxidation half reaction takes place. Zinc get oxidized by losing 2 electrons. Okay. At cathodic side reduction half reaction takes place. What will happen at cathodic side? Cu2 plus ions gains 2 electrons to give copper. Okay. These are the 2 half cells reaction takes place in galvanic cell. Net reaction for galvanic cell can be drawn from these 2 half cell reactions. Okay. Net reaction for this galvanic cell can be drawn from 2 half cell reactions. Okay. Now let us see the net reaction is Zn plus Cu2 plus gives rise to Zn2 plus Cu. Let us discuss the physical states of the species present in the net reaction. Here let us see zinc is in solid state and Cu plus 2 aqueous solution state and Zn plus 2 aqueous again and Cu is in solid state again. Here the ions which are in aqueous state has to be taken in the same concentration for construction of galvanic cell. That means the electrolyte of cathodic half cell should contain 1n Cu2 plus ions and electrolyte of anodic half cell also should contain 1n Zn plus 2 ions. Okay. So the EMF of galvanic cell which are constructed by means of the concentration of 1m solutions, EMF of galvanic cell is 1.1 volt. Okay. Net reaction taking place in galvanic cell or electrochemical cell. So now let us see another important aspect, that is notation of galvanic cell. So based on IUPAC rules, the notation of galvanic cell would be like this. Okay. So if one want to indicate the galvanic cell in simplest form, we can represent like this. While notating galvanic cell, the atomic state of anodic half cell should be represented at first, followed by ions or ionic state. This is also sometimes called as molecular state. Okay. After that, the anodic half cell is to be separated by 2 parallel lines, 2 vertical parallel lines which indicate salt bridge. And then ionic state or molecular state of cathodic half cell represented, followed by atomic state of cathodic half cell. Okay, this is IUPAC notation of galvanic cell.